So guys, as you can see there, we have a counter starting from 0 going up to 100 and repeating all over again. There we have the PIC16F877A microcontroller, and see, our counter is working like a charm. It goes to 100 and then starts over all over again. So it's a 0 to 100 counter. Guys, welcome to learning microcontrollers. In this video, I will show you how you can interface a PIC16F877A microcontroller with a 24 cross LCD JHD204A, and then we will run a counter from 0 to 100. So let's get started. So guys, this over here is our JHD20 cross 4 LCD. You can see it has two connectors, 16 pin each. They both are just duplicate. Either you use these 16 pins or either you use these 16 pins. They are exactly the same. Now guys, this over here is our PIC16F877A having 40 pins. It's a DIP vision. This over here is the JHD24 cross LCD. We are only going to use a top connector. And this over here is a 3-pin contrast adjustment resistor. This has 3 pins, 1, 2 and 3 mentioned on the body as well. And the LCD have 16 pins if you hold it like this from left to right. You connect the pin number 1 and 5 the LCD like this. Then you connect these pins to the pin number 1 of your potentiometer. Then you send it to the common ground like this. Then pin number 2 of your LCD will go to the pin number 3 of your potentiometer. Then the pin number 3 of the potentiometer goes to the VCC pin. In this way, your potentiometer gets the 5 volt and your LCD gets the 5 volt because PIC is being powered up from a 5 volt source. So whatever the source is powering up the PIC will also power up the potentiometer and the LCD. This potentiometer is only used to adjust the contrast of the LCD. Now guys, pin number 2 of your pin number 3 of your LCD is the contrast adjustment pin. You will connect it to the adjustable pin of your potentiometer, that is pin number 2 in this case, like this. Now pin number 4 is the RS pin. You may use any available digital input output pin. I'm going to use a pin number D1. Pin number 6 is the enable. I'm going to use a D0. Pin number 14 of your LCD is the data pin 7. I will connect it to the D7 of my PIC16F877A, 13 to the D6, 12 to the D5, 11 to the D4. And pin number 15 of your LCD is the LCD backlight positive 5 volt. You connect it to the 5 volt pin of your, that is the pin number 2 of your LCD like this. And pin number 16 is the ground of the LCD backlight power. You connect it to the ground of the circuit. These two pins, pin number 15 and 16, are only for the LCD backlight. If you do not connect them, your LCD will still work, but you will not have the backlight. So it will be difficult to see. So if you connect them, your LCD will also have the backlight. Now guys, these are the total connections. Now these 4 pins, 7, 8, 9 and 10, they are for the 8-bit mode. If you are using this LCD in the 8-bit mode, then you connect D0, D1, D2 and D3 pin, else D7, D6, D5, D4 are more than enough to make it work. So in our application, 4-bit mode is enough. So this is the circuit diagram. Now let me introduce you to the hardware, then we move on to the programming. So this over here guys is the hardware. As you can see, this is our PIC16F877A microcontroller having 40 pins, a DIP version. This over here is a JHD LCD. Here you can see this is a JHD204A LCD as shown in the presentation as well. And there at the back you can see is a PIC, and then we have the PIC at 3 connected to the computer. Simple hardware. Now guys, let's go to the MikroC for PIC to start the programming. So this over here is our MikroC for PIC. I have a lecture on this, how you can download and install this for free. Let me zoom in. I use the magnifier. Okay, let me zoom in like this. Click on File, New Project. This window pops up. Click on Next. Write the name of the project, JHD204LM PIC16F877A tutorial. So this is the name of the project I wrote. Select the microcontroller. I have PIC16F877A. The crystal I have at the pin number 13 and 14 is 16 megahertz. So I write that, click on Next and finish. Now guys, this window pops up. Before you do anything else, first of all, save your work. To save your work, click on Save button like this. And here you click on Save to save your work. Now guys, first of all, let's initialize LCD. To initialize LCD, go to the right. You have these MikroE libraries, expanded, system libraries, expanded. There look for this LCD library, check mark this. Expanded. Here you have the LCD-INIT command. Double click on this. This window pops up. Go down. In the example here you have these command. You copy them till here like this. Go back, place it above the void main. Now there you will write the pins you have selected. Like in my case, for the RS I have selected D1. For the EN, I have selected D0. For the data pin 7, I have selected D7. For data pin 6, I selected D6. For data pin 5, I selected D5. For data pin 4, I selected D4, like this. Now similarly do the same for the pin directions. So D1, D0, then we have D7, D6, D5 and D4. Now guys, if you use different pin configuration than the one I use, then you only have to change these to that pins which you are using right now. Now guys, this is how you declare the pins. Now go to the right. Here you have this LCD and IIT command. Double click on it. This window pops up. Here you have this command called LCD and IIT. You copy this command like this. Go back, paste it in the void mail like this. Now give some initialization delay, not necessary, but I always suggest you give it in the one time loop like this. Now guys, the LCD will get initialized after using this command with this pin setting. So our LCD is now initialized. Now we can go for the forever loop. Write down while 1, forever loop starts here and ends here. Now we need to run a counter from 0 to 100. For that we will need an integer variable. So I write int count. This is the variable. Now to make a counter, we may use any loop. You can use while loop, do while loop, or for loop. I will use a do while loop. Do while loop starts here, ends here, then you give a while, then inside it you will write the condition, and this is the syntax of the do while loop. Now first of all, our counter is 0. As soon as the forever loop starts, count equals to 0. So counter becomes 0. Now once we go into the do while loop, our counter is 0 by default, and counter is equals to count, that is plus 1. So counter is incremented by 1 as soon as we go into the do while loop. So this is nice. Now once the counter is incremented, after that we will make a condition that for how long it will be able to counter is less than 100. So counter will keep on incrementing by 1 until the counter do not reaches 100. As soon as it reaches 100, it gets terminated. That's all, and then it will repeat again. Now guys, the problem is that we have the counter ready, but how to display it on the LCD? Now to display it on the LCD, the problem is that you cannot display integers directly on the LCD. You need to convert it to a string. Now to convert this integer to a string, we need a command. Now first, let's write a variable which will store the converted string. So in MikroC for PIC, you do not have a string. So you have to use a char, because an array of chars is also a string. So I write count 1, maximum letters it can have is 8. So that's fine. So this is our string. An array of char is a string. Now we go to the right. Here you have this library called conversion. Check mark this, expand it. There you have this command called int to string, integer to string. Double click, copy this command from here. This command, go back, paste it below this command like this. Now you need to convert this to a string. Now place it above it, so we will also display the 0 as well. So int to string. Now what is the integer that you want to convert? So we want to convert whatever is in the count to the string and store it in this variable called count1. That is the string. Now whatever the integer was here is converted into a string and stored in this variable called count1. Now we need to display it on the LCD. Now this is the string, we can display it. Now go to the right. Here go down to the LCD library, this library. There you have this command called LCD out. Double click on this. In the example here you have this command LCD out. Okay, this is a CP one. You may use it, but we will use this one, LCD out command. You copy it, you paste it over here like this. Now guys, this is the row. Start writing from the first row, first column, what it should write, whatever is the counter. So counter value will be displayed from starting from the first row and the first column like this. Now guys, for how long the value should remain there, that we give some delay. This delay will decide what will be the speed of our counter. So we give a delay of like 200 milliseconds, like our each digit, each step will be displayed for 200 milliseconds. After that, it will get incremented. Now guys, this is how it's going to work. First of all, count is 0. It will convert the 0 to a string, and then it will display that it is 0. Then it will stay displayed for 200 milliseconds. Then it will be incremented by 1, and then it will override the next value, and it will keep on doing that until it do not reaches 100. Now we wrote 100 here because the do while loop have a property that it always executes one time. So that one time means that it will be executed, and then 99 time is left. That will be done by using this. So it will be total 100. Now after the code is executed, again it will repeat again and counter will become 0. But what I want to add is that we also clear the LCD. So once the loop is completed, it will clear the LCD if there is any rack backed value. So go to the right. In the LCD library, there you have this command called LCD CMD. In the LCD CMD library, there you have this command LCD CMD clear. You go back, you paste it after the code. So this will clear the LCD of any values, or you may place it above it. So as soon as the code start, the LCD is cleared, then it repeats the loop, a counter, and then it will go back over here, and again the LCD is cleared and counter is set to 0, and again it will start all over again. Simple. Now this is the code, we build it, check for errors. Okay, it's built, no errors. Now go to the PIC16 programmer tool. I also have a lecture on this, how to download and install it. Please go through that lecture if you don't have this software. Click on import hex file. This is the file we just created. I click on write. Okay, the new file is being written. We wait. Okay, let it write the new file. Wait. Okay, the file is written. We go to the hardware to see what is happening. Okay, let me show you the hardware. Okay, the file is being written. We wait simply. Once it's written, we will power up the circuit using the PIC16 programmer tool. Wait. Okay, it's done. We power up the circuit using the PIC16 programmer tool. I click on. Okay, the circuit is powered up, and you can see the counter is working. So let me show you better. So you can see the counter is going from 0. Okay, let me try to focus the camera. Okay, there you go. It goes 0 to 100, and then it starts all over again. See? So this is working like a charm. That is what how we wanted it to work. It is first row starting from the first column. So that is perfect. So this is it, guys. If you guys have any questions, you may ask. So we'll see you in the next lecture. Goodbye until then.